In this video, we're going to talk about parallel and perpendicular lines. So, as you take a look at this red and blue line here, do you think these are parallel? And does this information help at all? So, this one has a slope of 1, and this one has a slope of 4/5. So they're definitely not parallel, because if they were parallel, they'd have to have the same exact slope. They'd have to be sloped the same. So no, they're not parallel. Are these lines perpendicular? And here's a little more information for you. These lines are not perpendicular, even though they look like it. They look like they make a right angle, but they don't. It's not quite exactly a right angle. You can tell again because of the slopes. With perpendicular lines, remember the slopes have to be opposite reciprocals. Opposite just means if one's positive, the other's negative, which is the case here. Reciprocal means you flip the fraction. So if this one is 2/3, this one would have to be 3/2. Just flip that fraction. And that's not the case. So these are not perpendicular. So just as a reminder, parallel lines have the same slope, perpendicular lines have slopes that are opposite reciprocals. For example, like 2, which is kind of 2/1, if you were to flip that, you would get 1/2 and then make it negative. So those lines are opposite. The slopes are opposite reciprocals, and that does make a right angle. Or like on this one here, see how they have the same slope? So they are parallel. They'll have different y-intercepts, of course, but same slope. Also, I did want to mention, the only real exception to this is like, if you ever had a vertical line, these two vertical lines are clearly parallel. And remember, a vertical line is always x equals a number, like x equals -5 or x equals -4. Same thing with horizontal lines. If you had like y equals 3 and y equals 1, those both have a slope of 0, so they're also parallel. Okay, so we're just going to go through a few examples. First of all, we want to write an equation of a line parallel to this whose y-intercept is 12. If it's parallel to this line, then it has the same slope. I don't care what the y-intercept is, but it'll have the same slope. So my new line, remember a line is always y equals mx plus b. M is the slope, b is the y-intercept. So fill in -2 for the slope, and it told me the y-intercept is 12, so just put in 12 for the y-intercept. That's it. Let's try a slightly harder one. On this one, I want to be perpendicular to this line. The slope is currently 1/5, but if I want to be perpendicular to it, I'll have to get the opposite reciprocal. So flip it, now it's 5/1, or just 5, and make it negative. So my new slope is -5. The problem is I don't know what the y-intercept should be. It told me that this line passes through the point 1, -3. So 1, -3 is right here. And if it has a slope of -5, it would go down 5, over 1, or we could even go back 1, up 5. So there's the y-intercept right there. Sometimes you're not going to be able to graph it that easily though. And so if you don't want to graph it, here's how you would solve this kind of thing. I don't know what the y-intercept is. That's what I'm trying to find. But I do know that it goes through the point 1, -3. And so I should be able to put in 1 for x and -3 for y and have this work out. And so that's what I'll do. -3, put that in for y, put 1 in for x, and now I can solve for the missing y-intercept. I'll add 5 to both sides, and there we go. It's 2, just like we saw in our graph. So then I could come back here and instead of b, put a 2, because I know that's what it is. So this would be my final equation, -5x plus 2. Also, Another option that you have is a point slope formula. I don't know how often you all have used this the past few years, but I thought I'd mention it because it's going to be helpful in future math classes that you have. So you could do what we just did, but if you want to do point slope formula, all you have to do is plug in the slope and a point for x1, y1, and it will give you an equation of the line. So here's the exact same stuff. Again, I would want a slope of -5, so I'd put -5 in for the slope, and then I'd put this point in for x1, y1. Basically, I'm going to do y minus -3 equals the slope, -5, times x minus 1. And this is an equation for the line that we saw on the last one. If you want to simplify it and get it into y equals format, you can. This would be y plus 3 equals -5x plus 5, and then subtract 3 from both sides, and you'd get -5x plus 2. So same thing that we got before, just using point slope formula rather than the slope-intercept form. All right. This time I want an equation of a line that passes through 5, 2, and it's perpendicular to the line that passes through both of these points. So the first thing I need to do is find the slope of this line, and then I'll do the opposite reciprocal of that. So first I'll do the slope formula. Y minus y over x minus x, which is 3 over -4. So -3/4 was the slope of this other line. I want to be perpendicular to this, which means I need to flip it and take the opposite. So the opposite reciprocal would be +4/3. That's the slope that I want. All right. So I know my equation is 4/3 x plus whatever the y-intercept is, but again, I don't know it. So I have two options. I could just do point slope form like we just talked about, or we could plug in this 0.52 and solve for the y-intercept, which is what I'm going to do. So put in 2 for y, put in 5 for x, and solve for b. This is 20/3. And then subtract 20/3 from both sides. And we're going to get a decimal, a fraction there. So 2 minus 20/3. It's -4.6 repeating, which is -14/3 as a fraction. That's my y-intercept, which would have been hard to see on a graph, by the way. So let's come back here, and instead of b, we'll put what it is, -14/3. That's my equation. Again, if you like point slope formula better, you would just do y minus 2 times equals the slope, 4/3, times x minus 5. And when you distribute that, you would get the same thing that we got here. Also, I wanted to mention a problem like this. Is this a right triangle? It looks like it might be. Probably this angle right here would be the right angle because those look pretty acute. But how do I tell if it's a right angle? Well, it's exactly like what we've been talking about. If you want to prove something is perpendicular to each other, meaning it forms a right angle, their slopes have to be opposite reciprocals. So just find the slopes here and see what happens. This one has a slope of up 3 over 4, so 3/4. This one has a slope of down 4, right 3, so -4 over 3. So yeah, it is a right triangle because their slopes are opposite reciprocals. I know for a fact that that's a right angle. This can get a little trickier if the line it gives you at first isn't in y equals format. So if I want to find a line parallel to this, I need to know what this one's slope is. So to do that, I'm going to have to solve for y. So I'll subtract 2x from both sides. So 3y equals -2x plus 15. divide by 3, and that's y equals format now. So now I know the original slope here was -2/3, and if I want to be parallel to that, I will use the same slope. And it passes through this point. I'm going to do point slope formula real quick. Y minus 8 equals -2/3 times x minus -3. There we go. By the way, a little shortcut here if you like shortcuts. If you ever have a line that looks like this, where x and y are on the same side, the slope always ends up being negative this over this. See how we got -2/3? It's always negative this over this, because you have to subtract that over there and then divide by 3. So here's another example. If you want to use a little shortcut, the slope of this line would be -8 over -2, which comes out to be 4. If you're not sure about that, just get y by itself. Subtract 8x from both sides, so we get -2y equals -8x plus 20, and then divide by -2, and so y equals 4x minus 10. I want to be perpendicular to this line, so rather than a 4, I'm going to flip it and make it 1/4 and make it negative. So this line would be -1/4 x, and this is nice, it told me the y-intercept, 15. So that goes on the end. I think that's it.